Hello, everyone. Hope you're having a good day. This is going to be episode 1 of the basics of programming. In today's episode, I will be discussing data types and variables, what they are, why they're used everywhere, when to use them, how to use them, and how they differ across languages. Variables are probably the most important part of programming as a whole, and data types are just as important. So if you want to learn programming, you need to get a good understanding of both of these concepts. Okay, firstly, let's get something out of the way. Data types and variables are not the same thing. Sometimes you may hear the two words used interchangeably, but they are two different things. So firstly, let's go over what a variable is. A variable, at a high level, is the way in which data is stored within a program. It has four parts: the data type, the name or the identifier, the location in memory where it's stored, and its value. We'll discuss what a data type is in a moment. For now, all you need to know is that a data type describes what kind of data is being stored by the variable. The name or identifier is what we use to reference the variable. If we want to use the variable or perform some sort of operation with it, we need to be able to access it. This is usually done by referencing its unique identifier. Because of this, variables almost always have to be given unique names. If you have two variables with the name x and you try to use the variable x, which one's being referenced, the first one or the second one? You begin to run into problems when you have variables with the same name. The location in memory where the variable is located is simply just where the variable is stored. Just how much space the variable takes up depends upon its data type. And lastly, the value of the variable is what the variable is holding. If y plus 7 equals 15, then y must be holding the value of 8. Very similar to what you learned in elementary algebra. Now, let's move on to data types. Data types can be thought of as essentially categories for data. A variable's data type describes what kind of data this variable is holding. This is very important because it determines just how much space the variable will take up in memory and how the variable will interact with your program and other variables in it. So there's different kinds of data types. There are built-in data types, which are data types that are built in to the specific programming language, and there are user-defined data types that the programmer themselves define. Let's go through a list of basic data types that pretty much every language has. Firstly, we have the integer. An integer is just a whole number, positive or negative. You can think of 100, 30, 48, -5, 0, just a whole number. There are floating point data types, which is essentially just a number with a decimal point. You can think something like 13.48 or 1.982. A character is just a single character. It can be anything. It could be A, B, C, 1, 2, 3, at symbol, a hash, $sign, but just a single character. A Boolean is a data type that holds either the value of true or false. It has two states. So you could think of, for example, a variable called lamp on. If it holds the value of true, then the lamp is on. And if it holds the value of false, the lamp is off. Then we have the data type string. A string is a bunch of characters strung together. So, for example, if we wanted to have a variable that holds the value hello, well, if we did that with characters, we'd have to have 5 different variables. One holding H, one holding E, one holding L, another holding L, and another one holding O. But with a string, we can just have one variable that holds 5 characters within it and spells hello. Now, I know I just threw a lot of information at you at once, so now I'm going to open up a text editor and show you how these things actually work. So now I'm going to open up a text editor. Again, it does not matter what text editor you use, they all do effectively the same thing. And I'm going to create a file called main.cpp. CPP is the file extension for C++ files. If you were to create a file in, say, Python, the extension would be py. A file in Java would be .java. It just depends upon which programming language you're using. Now, to get us started, I'm going to write out some boilerplate code. You don't have to understand what any of this means. You don't have to worry about it. Just know that this is what is required to get the program to actually run and compile. Okay, so that's it. Again, you don't have to worry about what any of this means. This is just boilerplate to get us started. I guess I could give you an overview of what this does. Include IOStream up here. This is including a file called IOStream that stands for Input Output Stream. This will allow us to accept input and give output. All I want to do here is be able to print stuff, so I'm including IOStream so I can have output. So this int main right here, these parentheses and these curly braces, this is the main function, also known as the starting point or the entry point of our program. Essentially, when we compile this program down into an executable, the first thing that's executed is this main function and anything within these two curly braces right here. So anything that we put in here. So firstly, let's create a variable. Now, how do we create a variable? Again, we have to give it a data type. Man, I can't spell. A data type, an identifier, and then a value. So I'm going to create a variable with the data type int. This means integer. I want to create a whole number. I'm going to give it the name my variable. We're going to put an equal sign here, and I'm going to assign it the value of 32. And I'm going to remove this because this is just pseudocode. This will actually crash the program. It's not valid C++. So what do we have here? We have the data type, which is integer. We have the identifier, which is my variable. And we have the value, which is 32. And you could read this from left to right. Integer my variable equals 32. So now let's actually print this variable. So if I type stdcout my variable, all this is doing is printing the value of my variable. std:// cout, this is output. Then after this is what we're outputting. I'm outputting my variable. I'm referencing it by its identifier. And let's actually compile this program. G++ main.cpp. If we look, we now have a file called a.out. This may be a.exe for you, a.out. It doesn't matter. This is essentially an executable file, and we can actually execute it. And it prints 32, exactly what you would expect, because our variable is equal to 32. So what if we create another variable? Let's say int my other variable. And yes, there is a reason why I'm using underscores here instead of going my other variable. And that's because you can't actually use spaces in variable names. It has to be one consistent string. So we're using underscores as space delimiters essentially. Let's say my other variable equals my variable plus, let's say, 8. So this should equal 40, but we could test this out. We could print out, instead of my variable, let's print out my other variable. Save the file, come down here, compile again. If we run this, we get 40 as expected. So this is a little bit annoying here. You see right here it goes 40, and then the prompt in the terminal is printed directly after this. What we can do here is we can put a new line character. All this will do is I can actually show you right here. gcc main.cpp. Let's compile the program and run a.out. As you can see, it printed a new line after this, so this is all contained on its own line, so we can read it a little bit easier. I'll actually zoom in. This is a little zoomed out. My bad. So that is variables, a overview of variables in C++. They work very similarly in many other languages. And I can actually demonstrate what I was talking about earlier with variables having unique names. What if we were to create a variable called myVariable, give the value of 32, then we declare another variable, but we give the same name, myVariable, and we give it the value of 40. And of course, my other variable isn't around anymore, so let's delete that. What's going to happen? Is it going to print 32? Or is it going to print 40? Well, let's see. Let's compile this program. And as you can see, it doesn't even compile. You can see we have an error message in the file main.cpp. That's the file that we're working with in function int main. As you can see, that's the function that we're in right now. We've encountered an error on line 6. Read declaration of int myVariable. And it shows that this variable was previously declared here. This is exactly what I'm talking about. You can't have two variables with the same name. So if we wanted this variable, we would have to give it a unique name like my other variable, or delete it outright. As you can see now, if we compile the program, it runs exactly how you expect and gives us the exact output that you would expect. So what if we change the data type of this variable? Instead of an integer, what if I want a floating point value? I don't want to work with whole numbers anymore. I want to work with variables with a decimal point. Well, I just changed the data type from int to float. And now I can put a decimal point right here. And if I print this now, compile this program, and I run it, 3.2, exactly what we'd expect. So as you can see, I can put even more here and compile and run it. It gives you the output that you would expect. So now let's move on to Boolean variables. Again, a Boolean is a variable that holds either the value of true or false. You can think of it as on or off. So we would create a Boolean by putting bool we'll call this my Boolean, and give it the value of false. As you can see here, again, bool, you'll encounter this a lot. There's a lot of abbreviations and acronyms in programming to cut down on the amount of typing that you have to do. You can see them everywhere. For example, here, IOStream, this actually stands for input output stream. Int here and int main actually stands for integer. Bool here actually stands for Boolean. But it's a lot to type out all of these things, so we shorten them down to int. We shorten it down to bool. We shorten it down to IOStream. But just know you'll encounter this a lot. Anyway, back to the topic on hand. Booleans aren't typically something that you would print out, but we still can here. Standard cout, essentially just standard output, my Boolean. Let's of course also add a new line so that it prints on a new line, and if we compile this and run it, it gives us 0. Now you would expect it to print out something like false, but no, it actually prints out the integer 0. So what happens if we change this to true? And we compile this again, and then we run it. It prints out the value of 1. That's because Booleans are essentially just integers that hold the value of either 0 or 1. And you can kind of emulate what a Boolean does with an integer. Say, if this integer equals 1, do this. but if it equals 0, do this. Consider it on or true. If it equals 1, consider it off or false. If it equals 0, but Booleans just make this much more simple because you would also have to handle the case in which the integer might equal 3 or 4 or something else, a negative number. So we have Booleans here to handle that in a more efficient manner. Again, you wouldn't typically print out a Boolean. This is something that you would have internally in your program. For example, you might have a Boolean called, say, LED on. And if it equals true, then the LED light is on. If it equals false, then the LED light is off. Very useful. So now let's move on to characters, and we will type out char. Again, another abbreviation. Instead of typing out character, we're going to just type out char, call it my character. And we actually have to do something extra here. We have to surround this value in single quotes, and we can put whatever we want here. I'm going to put B here. And if we print this out, my character, put a new line here, save this, compile this, run this, it prints out B, just as you would expect. And again, this can be anything. It doesn't have to be a letter. It can be a number. It can be a symbol. Let's print out an ampersand, see if that works. And it, of course, does. And now the difference between character numbers and integer numbers is that you can't do math with character numbers. For example, if I have a character and give the value of 1, and I have an integer, let's call it my integer, and give it the value of 1, these two things are not the same thing. This is just a representation of the character 1. This is the integer 1. You cannot perform mathematical operations on this character, but you can on this integer. So if we make two variables here, two character variables, we'll name this one, let's just name it A for simplicity, give it the value of A. This one B, give the value of B. And we'll have a variable C, give it the value of A plus B. And if we print out C here, let's go up here, and we get the value of a 303 instead of C, as you might expect. That's because this is adding the ASCII values of A and B. Since these are characters, again, not integers, you can't really perform mathematical operations on them as you could with integers. So let's say we wanted to print the value hello. We'll name this character 1, give it the value of H. I won't make you sit through all of this. And we'll add a new line at the end, and this will print hello. But there's a simpler way to do this. We don't have to make a billion character variables. We can actually create something called a string. So we're going to have to include another file up here. You don't have to worry about that. This just lets us use strings in C++. So this will be std : string. You don't have to worry about what this std means. Just know that it's basically just this. But this is necessary. This string, we're going to give it the name my string and make it, we're going to have to use double quotes here, by the way. Instead of a character where you use single quotes, in strings you use double quotes. This denotes the difference between, is this just a character or is this a string? So we want a string, so we will be using double quotes, and we will type hello, and we'll get rid of all of these characters here. We don't need them anymore, and we will print out my string, and this will print out the exact same thing. This can be represented internally as character H, the character E, the character L, the character L, the character O. A string is essentially a variable that is an array of characters, and we'll touch on arrays probably next episode, but the very basic explanation of what an array is essentially what a string is. It is multiple of one type of variable combined into a single bigger variable. So a string is essentially just a bunch of characters combined into one variable. So now I'm going to jump over into Python and show you the same thing. I'm going to make a file and call it main.py. Py is the extension for, I just created a directory, my bad. I meant to create a file, call it main.py. Py is the extension for Python, much like CPP is the extension for C++. And you'll see here that Python is quite a bit less verbose. There's really no boilerplate at all. All we have to do is go, let's say we want to make an integer with the value of, let's say, 100, and I'm going to name it x. We would do x equals 100. If we want to print this, instead of going std cout, no, we would just go print. Actually, we'll get rid of these, and we'll print x. If I come down here, and I get the Python interpreter to run this file, it prints 100. Let me just come over here and zoom in a little bit so you can see a little bit clearer. Now, you'll probably notice a lot of differences between Python and C++. They are very different languages, but one thing you probably immediately notice is that we don't have to put the data type before the variable identifier. This is a feature of some languages. Python, for example, here is essentially inferring that since we provided the value 100 to this variable x, it's probably an integer. And if we put a decimal point here, 100.2, we come down here and run this file again, it is now a floating point value. And if we give x the value of c, a character c, and we run Python again, it prints out c. And if we give it the value hello, as in a string, we run this again, it now interprets this as a string. And we can even do this with the Boolean data type in Python. You have to put capital T true. Let's run this, and it prints out true. Now we can explicitly tell Python what type this is. So if I do this, I can type int here, and this will explicitly state that this is an integer. You can see it runs fine, and there is actually something similar to this in C++. Let me just get rid of all of this garbage here. If instead of providing a data type, I use the word auto, it will automatically infer what kind of data type I'm referring to. So if I type auto x equals 100, and I print x here, it will interpret this as an integer, as you can see. If we run that, it will interpret it as an integer. If I change this to 0.34, it should now interpret this as a floating point number. If I change this to a character, it will now interpret this as a character, and so on and so on. You see what I mean here. Typically in C++, you wouldn't want to use the keyword auto like this. It's not really meant for when you're using very basic data types like characters. This is more meant for in C++ when you have really, really long data types. It's easier just to type auto than have to type this constantly throughout your program. For something like this where it's just a simple character, you can just type character. You don't have to type auto. But this is essentially the basic overview and the basic gist of variables and data types. You now have a basic understanding of how they work and how to use them. And variables are very important to programming, often, almost always, they're used in conjunction with each other all the time. Another important thing to point out is that what we've been doing is declaration and assignment. When you declare a variable, let's say integer x, and you assign it a value, let's say 10. And if we print this out, as I'm sure you expect, it will print 10. Now you don't actually have to do these things at the same time. We can just declare the variable x here, declaring a variable with the type integer, the name x, and then we can come down here and say x equals 10. And if we run this, we get the exact same output. This is called assignment. We are assigning the variable x the value 10. And we can actually declare multiple variables here. If we put commas between them, I can declare x, I can declare y, then I can declare z. We'll say y equals 150, z equals x plus y. So we can print x, and we will get, well, as you can see, we got an error here, expected semicolon before std. I actually forgot a semicolon right here. As you can see throughout this program, I've been putting semicolons everywhere. This is essentially a C++ thing. It's present in a lot of other languages, but you didn't see this in Python. It essentially means this statement right here is done. To signify that this statement is over, we put a semicolon. Now if you'll notice, this isn't a thing in Python. Python is designed to be a lot simpler and a lot easier to read and understand than something like C or C++. So they've done away with the semicolon need, but in C++ you actually have to have these semicolons everywhere to signify that, hey, this statement is over. So if I compile this now, as you can see, it compiles fine, and if I run it, I get 10. If I replace this with y, and I run it, I get 150. If I replace this with z, and I compile and run this, I get 160, as you would expect. So that is declaration and assignment explained. There's also something known as mutability in programming, and mutability determines how a variable can be mutated. So if I create an integer here, integer x, give the value of 10, and then I come down here and say x equals 40, and I print this out, print a new line too, so it looks nice. We compile this, and we run it. It prints out 40 because we declared a variable, gave it the type integer, gave it the name x, gave it the value, assigned it the value of 10, then we reassigned it the value of 40. And we can do that. We can do this as many times as we want. We could say x equals 100, then we could say x equals 9,000, and if we compile this and run it, we get 9,000 because it was assigned 10, then it was assigned 40, then it was assigned 100, and then it was assigned 9,000. Now we can actually prevent this variable from being mutated like this by making it constant. In C++, you would do this with the const keyword. This is short for constant, basically saying that this variable should never change. So let's just remove these other ones. So if we try to compile this now, we will get an error. Assignment of read-only variable x. When we try to assign it the value of 40. This variable is constant and it can no longer be mutated. So if we get rid of this, compile the program, run it, we get 10. This variable will have the value 10 and it cannot be mutated. So interestingly, in Python, there isn't actually a way to make a variable constant. There is no const word in Python. If we try to run this, main.py, invalid syntax, we can reassign this variable as much as we want. Typically in Python, if you see a variable with the identifier in all capital letters like this, it means that this variable should not be modified. Of course, that doesn't actually change anything. You can still modify it all you want, but that is the convention. Most languages do, however, have support for constants. In fact, in some languages, variables that you declare are constant by default and can't be mutated, and you have to actually mark them as mutable to be able to mutate them. This is a feature in languages such as Rust. So variables are very often, of course, used in conjunction with each other. I can show you a quick example. So let's say, a string. We're going to have it be name. The name, we're going to have it be, let's say, John. The name will be John. And then we'll have as you can see, I forgot a semicolon there. And we'll have an integer variable here. We'll call it age. Let's say John is 35 years old. And we'll have a float here. We'll call it height. Let's say that John is 5'9". And we'll have a boolean here. Let's call it is alive. This will tell whether John is alive or not. We'll set this to true right now. We want John to be alive. And we'll have a character variable. Let's say John is taking a test. This will be his grade. We're gonna give him an A. So we can print this out. With printing, you don't have to just print variables. You can just put strings in here as is. We can put hello and then put a new line here. And this, I forgot a semicolon, but if we compile this again, this will run just fine. Everything doesn't have to be a variable. So let's say name, and then we'll print out his name. We'll print out the name variable. Then we'll print out a new line, then age, print out his age, then a new line, and we'll say height. We'll print out his height, then is alive, and we'll print out is alive. Of course, this is going to print out not true or false. This is going to print out 1 or 0, but that's fine. We know what that means now. And we'll print out his grade, the most important part of all of this. Print out grade. And you can see we get some line wrapping. This is a very long line. We'll print out a new line here. If we compile this, hopefully there's no errors. There is none. There we go. We have a nice little program. Name, John. Age, 35. Height, 5'9". Is alive. Yes, he is alive. 1 equals true, 0 equals false, remember. And grade is A. And of course we can change any of these anytime we want. I could even change grade F, make him 4'2", make him 5 years old. And this program, if we compile it again, will reflect the changes that we just made. Variables are a great way, one of the only ways, to store data and information in programming. And now you have a basic understanding of how variables work. We may actually do this in Python too, just to show you in that language as well. Let's say, so we'll have name. It will be, let's say, Mary. Age will be 40. Let's say height be 6 feet tall. I had to put an equal sign there. Height. What else did we have? We had is alive and grade. Alright. Is alive. That will be, let's say false. Or no, let's say true. I don't want it to be false. Remember, true in Python has a capital T, unlike in C++. And then her grade will be, let's say B. So if we print this out, again, you can just throw stuff into print, like we can just throw hello into here. We don't have to have variables. Python 3 main.py. It prints the word hello. So if we come down here and compile this, so as you can see, we ran into an error here. Can only concatenate string, not integer, to string. Essentially what's happening is it's seeing this plus sign and seeing this integer here named age, and it's trying to treat it as a string, but this isn't a string. This is an integer, as you can see right here. So what we'll do is essentially just convert this to a string, and we will have to do the same thing for height because height is a float. Oops. And the same thing for isLive. isLive isn't a string either, it's a boolean. Oops, not C++. Python. And finally, it works. Name Mary, age 40, height 6 foot, isLive true, and grade is B. So that's going to be all for today. We discussed data types and variables, what they do on a basic level, trying to give you a basic understanding of what they are and just how important they are. Feel free to install Python or C++ or any language of your choice on your computer and mess around with variables, see how they interact with each other, see if you can get an even deeper understanding of them. If you have any questions, feel free to leave them in the comments. Thank you for watching, and have a good rest of your day.